Okay, so the next video is on rules for significant figures. So we talked about this a little bit in lab, and now this is basically a repeat of what you guys learned in lab, but there'll be more examples, so hopefully you can get the rules for sig figs down. So the first rule for significant figures is that non-zero integers always count as significant figures. So non-zero integers are all numbers that are not zero. So 3.25 grams has 3 sig figs. 4.3999 grams has 5 sig figs. So all non-zero numbers count as significant figures. Zeros, again, that's where it kind of gets tricky. So leading zeros are zeros that precede all of the non-zero digits in a number. These do not count as significant figures. So if you have something like 0.00035, that's only 2 sig figs. Or 0.00135 is 3 sig figs. Okay, sandwich zeros are zeros that are between two non-zero digits. And these always count as sig figs. So for example, 3028 pounds has 4 sig figs, and 4.003 grams has 4 sig figs. So again, if the zeros are between two non-zero digits, then they count. Trailing zeros. So trailing zeros are zeros that are at the right end of a number. These only count sometimes. So they only count if there is a decimal place. So a few examples on this one. So 100 is only 1 sig fig. There's no decimal place. Those trailing zeros here don't count. 1.00. This has 3 sig figs. Okay? 100.0, that's 4 sig figs because all those zeros count. So even if the 0 comes after the decimal place, that still counts. And sometimes in your textbook, they like to show you that they're sig figs, so they'll put a dot after a number. So in this case, 100 would have 3 sig figs. But that's only true if there's a dot. Now lastly, exact numbers are said to have an infinite number of significant figures. So exact numbers are counting numbers and definitions. So something like 8 donuts, 23 students, or 1 liter equals 1,000 milliliters. These are all considered exact numbers. So these numbers don't count towards sig figs. Okay, so now a few examples. And this is from your textbook. So let's say that you have a number that's 0.105 grams of caffeine. This number, they have some leading zeros. So these two zeros are leading. So they don't count. So you're left with these three numbers. So there are 3 sig figs. Okay. B, 0.050080 grams. Okay. Now this again has some leading zeros, so those don't count. but all of these numbers count. I'm going to abbreviate it to SF. So 5 counts because it's a non-zero number. The 2 zeros count because they're sandwiched. And then this last 0 also counts because it's to the right of the decimal place. So this number has 1, 2, 3, 4, 5 significant figures. Okay. Now C. Sometimes you'll be given or write numbers in scientific notation in order to show how many digits are significant, especially if there's zeros. So this example, the number is 8.050 times 10 to the negative 3 seconds. So the numbers that count in scientific notation are whatever this coefficient is. So in this case, there are 4 sig figs. So all the numbers in the coefficient, this number here, in any scientific notation, that is your coefficient. So all the numbers in the coefficient count toward the sig figs, or count as sig figs. Okay, so next section will be about, let me change the color back to black, how to use significant figures in mathematical operations. So first rule is multiplication and division. So the rule for multiplication and division is the number of sig figs. Okay, SF again, I'm abbreviating it, is the number of significant figures in the result is the same as the number that you used in your calculation that is the least precise. So least precise number. So the least number of significant figures. Least precise. Okay, example. 4.56 times 1.4. Okay, you do that math, you get 6.38. Now let's look at these two numbers. So this number has 3 sig figs, and this number has only 2 sig figs. So that means that our least precise number in our calculation is 1.4, and therefore it determines how many sig figs our answer will have. So we're going to mark our answer here because it should only have 2 sig figs, so that's that 3, and then we're going to round. So your final answer would be 6.4. Okay? Now next, this is the rule for addition and subtraction. So keep in mind that the rules that I'm telling you go for both addition and subtraction for the addition and subtraction rules, and multiplication and division for the multiplication and division rules. So the rule for addition and subtraction is that the result has the same number of decimal places as the least precise measurement used in the calculation. So example, 12.11 plus 18.0 plus 1.013. Okay, so addition and subtraction, you always look at the number of decimal places. Whichever number has the least number of decimal places is the number that is the least precise. So remember that less decimal places means that it's less precise. So in this case, 12.11 has 2 decimal places, 18.0 has 1 decimal place, and 1.013 has 3 decimal places. So in this case, 18.0 is our least precise. And that will determine the number of decimal places in our answer. So again, we're looking at decimal places, not significant figures. So in this case, our answer would be 31.123 before we round, and the answer should only have 1 decimal place, so I'm going to mark that first decimal place, and then if we round our answer, we get 31.1 as our final answer. So again, addition and subtraction, you look at the least precise measurement and your result should have the same number of decimal places as that least precise measurement. Okay, so I was talking about rounding, but we'll go through the rounding rules really quickly. So these are simple rules you guys should know, same ones that you would use in math. So rules for rounding. Okay, so 1, if you're doing a series of calculations, keep your digits until the end. Do not round in the middle of a calculation because you're going to get rounding errors. Keep your extra digits until until you're done, until the end. Okay, so now our actual rounding rules. So if the digit to be dropped is less than 5, then you round down. So basically, whatever the number to the left of that will stay the same. So example, if you have 1.33 and you need to round it to this first decimal place, then your answer would be 1.3. So this number stays the same. Now, if the number to be dropped is greater than 5, then you round up. Okay, so in this case, we have 1.36 and we need to round it to this first decimal place. So because this number is greater than 5, then we're going to round up to 1.4. Okay, now some calculation examples. So example 1, and this is a division problem. So 1.05 times 10 to the negative third divided by 6.135. Okay, now our answer, if we did this math, would be 0.000171149. Okay, so now let's look at how many sig figs each one of these numbers has. So this number, 1.05, has 3 sig figs. This number has 4. Okay, now remember the rule for multiplication and division is whichever number is the least precise determines how many significant figures are going to be in your answer. So this 1.05 times 10 to the negative 3 has the least number of significant figures. Therefore, your answer should only have 3 significant figures. So I'm going to mark this 1 here because these leading zeros don't count. Remember your rules. So our answer would be 0.000171, or you can write it in scientific notation as 1.71 times 10 to the negative 4. Okay. Second example is addition and subtraction rules. So we have 21 minus 13.8. Okay, now here, this number, remember we're looking at decimal places here, so the number with the least number of decimal places tells you how many decimal places that your answer should have. So 21 has no decimal places. And 13.8 has 1 decimal place. Okay, so our number that is the least precise is 21. So our answer, if we do the math here, we would get 7.2. But since our 21 has no decimal places, our final answer should also have no decimal places. So you would round here to 7, and that would be your final answer with the proper sig figs. One more example, combining addition and subtraction and multiplication and division rules. Example 3. So this problem is in the back of your book. It's 37B if you want to look at it again. So this is the problem. 6.404 times 2.91 divided by 18.7 minus 17.1. Okay. So when we do a problem like this where we're having multiple types of math that we're doing, so you follow the rules just like you would in math, the order of operations. So the first thing you would do is the multiplication. So we're going to write our answer, but we're going to keep all of the decimal places for now. So 18.63564. Okay, now one thing we need to do is look at this number up here and determine how many significant figures this result should have based on our calculation in the numerator. So 6.404 has 4 sig figs, and 2.91 has 3. So our answer should have 3. So we're going to mark this 6 because that's how many significant figures the top result would have. Okay, now if we do the math on the bottom, both of these numbers have 1 decimal place, so our answer would also have 1 decimal place. So if we do the math there, our answer would be 1.6. And I'm going to go ahead and mark that anyway, but you guys know that 1 decimal place is what our result should have. Okay, so now moving on, this number here follows the rules for multiplication and division because we're dividing 18.63564 by 1.6. So in this case, our answer is just going to have the same number of significant figures as the least precise number used in the calculation. So 1.6 has 2 significant figures, 18.6 has 3. So our final answer should have 2 significant figures. So if we do the math, again, keep all your digits until the end and then round, we get 18.647275. Okay, that's all of our digits. And then remember, we're going to be rounding to 2 sig figs. So that means our answer is going to be rounded to this ones place. So our final answer is going to be 12, because we're going to round up since that number is greater than 5. Okay, so that's it for sig fig rules and using significant figures in calculations. Now you guys will get a lot more practice as we go through the semester, because you'll be using sig figs in every calculation that you do. So just keep that in mind when you do practice problems or you do problems on quizzes. Make sure that you're following the rules for sig figs.